Hey, how's it going, guys? Yeah? Not jet lagged? A little bit? All right, cool. Well, today I want to talk to you about the fact that I think Ruby is the best language to build AI web apps. So some of you know me already, so I'm Carmine. I'm the author of RubyLLM and also the founder of Chat with Work, which is an AI coworker. And I started using Ruby in 2009. Then I switched to basically studying AI. So I started doing just Python and AI for most of my career. And then I switched back to Ruby since 2024. So I've seen Python and I've seen AI. And I'm here to tell you that maybe that era could be over. So when people think about the languages to build AI apps, what do they think? Of course, Python. And maybe JavaScript these days too. And it makes sense, right? So Python owns the AI space. We've had all the libraries to create models. So we had NumPy, SciPy, scikit-learn, TensorFlow, PyTorch. And JavaScript owns the web, right? They attracted a whole generation of developers that basically switched from front-end to being full stack because now they have to learn only one language. And Ruby often gets passed over. But I think that's a huge mistake. Let me show you why. So AI app development was, first you get a data set, then you train a model, and then you build an app around it. AI app development now is very different. The data set is the internet. To train a model, it takes millions of dollars. So the only thing that's left is really to build the app around it, at least for us folks. Really, AI development now looks like this. So the AI training library ecosystem is now irrelevant for AI app development. But why Ruby, right? Well, let's explore it by looking at the top LLM libraries in the different languages. LangChain for Python, AI SDK for JavaScript, and RubyLLM for Ruby. So let's look at a simple chat. This is Python LangChain code. First, you need to import two things. You need to initialize the chat model, and you need to also specify which provider you're using. And then you create an array of messages. You need to initialize a human message, and then you invoke the model on these messages. Simple enough. AI SDK is next. First, we need to import generate text. Then we need to import the actual provider, and then we can generate the text. Can we do something better? Maybe we can. This is how it looks in RubyLLM. So you just require RubyLLM, and then you use RubyLLM.chat in order to create a new chat instance. You pass the model just with a simple string, and then you call .ask with whatever prompt you have. We can do even better through convention over configuration and Zeitwerk. What about multi-turn conversation? So this is a LangChain example. First, we need to import a lot of things. Then we need to initialize the chat model, initialize the messages, invoke and get a response. Then we need to append the response to the messages, and then append a new prompt, and then we can invoke it again. What about AI SDK? We kind of have to do the same thing, right? With also a lot of different syntax. Can we do better? I think we can. This is how it looks in RubyLLM. We first require RubyLLM, we initialize the chat, then we just say hello, and then we just ask for telling us more. And inside, RubyLLM is keeping track of all the messages. What about streaming? So this is how it looks in LangChain. We have to do the same things. And now we're iterating over the chunks. And in order to separate, for example, the reasoning steps, we have to do a beautiful list comprehension, which basically selects the reasoning chunks from the rest. And then we can print the reasoning chunks or the actual chunks. This is in AI SDK. We have to do all that. And then once we're actually streaming the tokens, we have to separate them by looking at the part type. What if we can do something better? So this is how it looks in RubyLLM. You just print the chunk.thinking, the chunk.token content. What about multimodality? Well, it turns out you need to download your own image, and then you can actually pass it, but you have to actually structure all of this by yourself. And remember all of that, by the way. I think we can do better. Just initialize the chat, ask to describe the weather in that image, and just pass it to an argument. We figure out if it's a URL, if it's a local file, what MIME type it is, and we pass it correctly. What about other types of files? Well, we can actually parse all types of files. We will figure out which MIME types it is, and you can pass them all at once in one prompt. For AI SDK, I wanted to show you a tweet by the CEO of Vercel, where he was very proud to announce that chatting with a PDF is the hello world of AI apps, and it's now about 20 lines of code. And I proudly commented this. Structured output is also supported. So this is how it looks in Python. I actually kind of like this syntax. This is how it looks in AI SDK. A little bit more convoluted. But I think we can do better. And this is how it looks in RubyLLM, thanks also to the RubyLLM schema gem. Tools is another example. Again, I'm going to go and just speed up a little bit just for you guys to see it really quickly at a glance. Also, pretty nice syntax. But again, the messages, you need to specify them in a really strange way, in my opinion. And this is how it looks in AI SDK. You need to specify the entirety of the tool description and all the parameters in a really strange syntax. And this is how it looks in RubyLLM. Just description, params, execute function. And we can also support nested schemas in case you have more complicated ones. So we're the one API for 12 providers. We support more than 800 models out of the box, plus any OpenAI compatible provider, and all the models from Hugging Face and Model Scope that you can run locally through GPU stack, which also runs VLLM and other inference, like TensorRT LLMs, for example. So you can run them in production as well. We support Anthropic, Amazon Bedrock, Anthropic, DeepSeek, Gemini, GPU Stack, Mistral AI, etc. And in order to change the model, you don't need to specify the provider at all. In fact, you can see it here. And if we have multiple providers for the same model, you can simply specify the provider you want. And this is thanks to our model registry, which is now powered by models.dev, thanks to open code. And so it's very accurate, it's very up to date, and you can actually price your app, and you can refresh it with the latest models anytime. And also, you can explore all the models that we have by provider, capability, etc. And this is the code to do it. Another example that I wanted to show you is about tracking the usage. So in order to price your app, you need to know how much you're using. This is through LangChain. Can you guys spot where actually the token usage is? Right. What about now for Claude Sonnet 4.5? Kind of hard, right? What about Gemini 3? It's not there. What? So it turns out you need to pass an extra argument in order to get it from Gemini 3. But we do all that. And we do it for every single model and every single provider. So this is for GPT-5 Nano. This is for Claude Sonnet 4.5. And this is for Gemini 3. As easy as that. And it makes sense. It's just response.tokens.input, output, or thinking. Also, we have a lot of other features in RubyLLM. I'm not going to go through every single feature we have, but I wanted to show you a lot of the things that we can do in one line. So, of course, you can start a chat. You can also paint an image. You can also embed some text, moderate, and transcribe audio. And of course, we're in the Ruby community, so we need to have a Rails integration. I'm going to show it to you by showing you going from 0 to a chat UI in less than 2 minutes. OK, so we're creating a new Rails app. Oh, it's not playing. It was playing here. Let's see. Oh, there we go. Awesome. This is real time, by the way. So now we're going to the chat app. We're just going to add RubyLLM. And we're going to first install it. So it's going to create a migration for chats, messages, tool calls, and models. And then it tells you what to do next, which is Rails DB migrate. We're actually loading the models from our model registry inside the DB already, so you're ready to go. Then you just add your credentials. And we can chat already. And now we can say, also from the Rails integration. So the chat.create, chat is the Rails model in this case. And now it's going to say hi to the conference. I didn't have time to update this video, I'm so sorry. There you go. Now we're going to install the chat UI, switch to the browser, and we have our chat. This was 1 minute and 40 seconds. And we were also like just taking some time to test it out. Yeah, and it goes around that, so I was like, no, Ruby is the best, guys. What are you talking about? Now we're starting a new chat from there. And there you go. And this is all made with Hotwire. So it's using like default Rails. And it's streaming all the tokens as well. And now you can see the models interface. And we can also refresh it from there. There you go. So let's look at the code. You may think like this is probably very complicated. No, it's not. So this is the entirety of the streaming job. So as you can see, we have like a chat.ask content with a block. So we're streaming the chunks. And we basically append the chunk to the web page. So if the chunk is present. This is the controller. So essentially, every time we create a new message, it's going to add that background job. And that's it. These are the models. And we're using access message, access chat, access tool call in order to inject all of our methods inside your models. And you can change the name of the models if you want. And also we have the migration generator that can change the name of these classes from there if you want. That's it. Now, it also scales thanks to the Async gems by Samuel Williams. And I wanted to briefly talk about this. So in a classic job queue, if you have 100 max workers, your 101 chat is going to wait. And also, 100 chats means that you have 100 workers, means that you have 100 DB connections. On top of that, they use threads, and threads actually are a little bit slower to be created, to be scheduled, to be switched. So I'm going to show you a comparison in a second about that. And the workers, by the way, they're 99% idle or more because they're just waiting for a token. Instead, with a sync job, you have no max workers, which means that you can scale as much as your resources allow. Also, 100 chats means 100 fibers, and you can reuse the DB pool. You probably need to expand it a little bit. And the fiber creation and fiber switching, it's so much faster. And it works by yielding at I/O time, so you have no wasted resources. It only runs in your CPU if there is actually some CPU-bound code to be run. So after all this, I wanted to show you also how easy it is to have multi-agent orchestration. So this is a code, this is 17 lines of code, and it actually does like 3 different reviews of your code, and then it summarizes it with a 4th agent. So it uses different models, just for an example, and it runs inside an async block. So these 3 agents actually run in parallel, or concurrently, technically. That's it. That's a code reviewer with 4 different agents. So why this is only possible in Ruby? First of all, blocks are a language feature. So in Python and JavaScript, you need specific, explicit asynchronous generators or callbacks in order to approximate the same flow. Ruby has a dedicated block syntax, which is separate from the method arguments. And you can also forward it. And it means that it can accept the block, it can forward it with ampersand, and you can stream it without any extra ceremony. This is the code from the implementation. Also, DSLs via class macros, plus simples, plus optional parentheses, make it so easy and so beautiful code. So in Python and JavaScript, you will need dicts, you will need objects, and a lot more punctuation. Instead, this kind of reads like English. And the implementation also is really simple. Open classes. You can monkey patch any classes you want. And we can just use class macros like access chat in order to do that. And this is in the implementation. Also really beautiful and simple. So code aesthetics and programmer happiness are fundamental principles of Ruby culture. We all know this. That's why we're here. Now, let's look at a case study of exactly the same library ported to JavaScript. So there's been a kind folk that actually has done this job. And I think it looks pretty nice, but I'm maybe biased. So you can see from here, there's a lot less code to achieve exactly the same things than AI SDK. If you guys like JavaScript, maybe try this out. So you see there's NodeLLM.chat, chat.ask, and you can also stream chunks. Now, let's look at NodeLLM's reception. This guy posted it on the Reddit JavaScript and Node. Unfortunately, has gotten 0 upvotes. Everybody has downvoted him, and he has only gotten 14 stars on GitHub. And these are the top comments. This breaks my heart. How is this different from AI SDK? It's always fun when new AI bros post stuff. They all look and sound the same. Also, totally unnecessary. If you don't understand how Node.js works as a program and rely on AI, then AI is only going to magnify that disconnect. There were no other comments. This is heartbreaking. Instead, let's look at how the Ruby community has received RubyLLM. Again, kind of exactly the same design. This has been the recognition. #1 on Hacker News, 4 days later. 1 week later, 1.7 thousand stars on GitHub. And now we are sitting at 3.5 stars, 4.7 million downloads. Many times #1 Ruby repository in GitHub. And quotes like these, like RubyLLM is a better tool than any other Python lib I used before. I really don't understand how it's not more hype. And it's used in many, many companies. These are only the ones that agreed to put their logos in. And even 37 Signals chose RubyLLM in Fizzy before scrapping their AI part. But this was a highlight for me. And a lot of people started building on top of it. So right now we have a huge ecosystem of a ton of libraries. Many of them actually came out in the last 2 weeks. So we have RubyLLM agents for Rails agent engine with DSL, reliability patterns, and dashboards. We have RubyLLM monitoring for a Rails dashboard with costs, latency, and errors. We have RubyLLM instrumentation for active support to notification events. We have RubyLLM semantic router for semantic routing of agents and tool selection. We have RubyLLM semantic cache for repeated prompts. We have RubyLLM NCP for MCP support. RubyLLM schema, which is actually a dependency, and you've seen it already, to create JSON schema. And RubyLLM template for having prompt templates in specific folders is very opinionated. RubyLLM skills, which is an agent skill library for essentially cloud code. And RubyLLM Tribunal, which I'm really excited about. It's an evaluation tool with an LLM as a judge. And also there is an open PR for OpenLLM Emetry. I don't know if I'm pronouncing that correctly, which is OpenTelemetry observability for LLM apps. This is great. So what I want you to leave you is with this. RubyLLM makes LLMs simple and elegant. And Rails is the fastest way to ship a real web app. Also, Ruby has the best developer community in the world. This is the proof. All you guys. So I think Ruby's moment in AI is here. All we need is to go ship AI apps and share them. Share them with the world. Show them what we can do. Thank you.
Impressive stuff, Carmine. Impressive stuff. Forgive me for mispronouncing your name before. Wow. We have a little bit of extra time. Would we like to open it up for a few minutes for questions? Carmine? Okay. Any questions for Carmine?
And how that made it Ruby better, and of course I believe that Ruby is better, but wouldn't you be able to achieve the same thing with lambdas?
In another language, you mean?
In Ruby, yeah, I guess in Python lambdas are more limited, but I don't know about JavaScript. You'd have functions, I guess, in JavaScript?
Let me think about this and get back to you.
Okay, no problem, thank you.
One or two more?
So real-world applications involve more than just interactions with LLM, right? There's things like memory, and also things like RAG, and nowadays model fine-tuning. Are you thinking about it? If not in this gem, like, do you have any other projects in the works to make it easier for Ruby? Because I've looked at your gem, been very impressed with it. I've had the same thoughts about LangChain, but if you're trying to actually build any kind of real world app, all of those other things matter, right? So,
Right. When you say memory, what do you mean exactly?
agentic memory, for example, if you're trying to build agentic systems.
Right. So there's certain decisions that I don't think we're ready to take. When I build something in RubyLLM, I'm ready to make that decision and make it stick. So I think memory could be implemented in so many different ways. Could be, for example, just a text file where you put everything in, or it could be a database. It could be whatever you want, right? And when there's that type of decision to be made and we're not ready yet, it's going to be hard to put it in RubyLLM.
Yeah, that's look cool. As far as I remember, I tried to use it once. LangChain on Python, like maybe 2 years ago. And as far as I remember, there is a tool to a full vector database and mount it to the LLM and to give LLM, it's like as private storage, something like that. Is it something like this in your library?
No, and the reason is actually the same exact reason as that. So right now, we've been seeing a lot of change between the classical RAG, which uses embeddings, to a much more agentic approach to it. Even Chat with Work actually got a refactor completely. So I used to have a classical RAG with embeddings, and now I don't even sync the Google Drive of the person. I actually have a tool that then searches and using the search API of Google Drive in order to get to the destination. And that, I think, is a much better approach because, first of all, embeddings, sure, they're more semantically driven, but actually keyword search still actually works most of the time. And LLMs are pretty good at figuring out when they need to search again. So we've seen a shift also. I don't know if you notice also in the community that not that many people use embeddings and chunking anymore for this, except for really specific applications where you combine them with typical information retrieval techniques like BM25 and stuff like that. Does that help?
Excellent, Carmine. Thank you.